all, this is Mr. J. We're doing chapter 3, section 5 in this video. After today, we should be able to solve systems of three variables using elimination. Solve systems of three variables using elimination. So in earlier videos, we talked a lot about how to solve two variable systems using substitution and elimination. Today, we're going to apply elimination to a three variable system. It is possible to solve these types of systems using substitution, but I usually find that's more trouble than it's worth. Elimination, in most cases, is the best way to do it. So first off, we've got a question. Okay, how many equations would you need to solve this? So we have the single equation 2x minus y plus z equals 4. Well, obviously we can't get a numerical value for x, y, or z with just one equation here. So how many equations would we need? The answer is 3. Because remember, the number of equations must always match the number of variables. So if we have two variables we have to find, two equations is good enough. If we've got three variables we have to find, then we need an additional equation. We need 3 in order to solve it. Let's take a look at example 1. So we're going to solve this system by elimination. We've got 2x minus y plus 7 equals 4, x plus 3y minus 7 equals 11, and 4x plus y minus z equals 14. Now, none of the math we're going to do in this video is all that complicated. I mean, we're going to be like adding, subtracting, doing some simple solving of equations at one point. We might have to multiply here or there. Nothing really out of this world. What makes these problems worthy of an Algebra 2 problem is the decision making that's going on. That's all that changes this from like just basic operations into an algebra problem. We have to look at this and figure out why we're doing what we're doing. Because there's lots of different ways we can attack these. The first big decision you always need to make is what variable do I want to eliminate? That's always your first thought. Okay, so I've got x, y, or z. In these three equations, which ones does it look like we're closest to being able to eliminate? Or maybe not closest, but are the easiest to eliminate? Because I definitely see one. I think the easiest to eliminate would be the z's. Because remember, when we're looking for elimination, we always want to have the same coefficient, but opposite. So opposite coefficients. So the same number, different sign. That's what I meant to say. We want opposite coefficients, and we're pretty close to that here. We've got a positive 1z, a negative z, and a negative z. So they're all the same number, and we've got a mixture of positives and negatives. So that's what we're looking for. Now, to keep this a little bit more organized, I'm going to label these equations A, B, and C. You don't have to do this. It just makes it a little bit easier to talk about it as we go through this. Now, what we want to do is we need to pick 2 to eliminate. Or 2 where we can eliminate our chosen variable. Remember, we're trying to get rid of Z. We're trying to eliminate Z. Let's pick A and B. I think if we pick those two and we add them together, we'll get rid of z. So let me copy them down here. So it's 2x minus y plus z equals 4. That's A. And x plus 3y minus z equals 11 is B. And now we can just combine them. Use our elimination step. The x's combined, we get 3x. The y's, negative y and plus 3y become 2y. The z's cancel out, which is what we want to happen, and we get equals 15. Now we have to keep in mind, why is this better? Each step of the way when we're solving systems, we want to know, okay, how are we moving closer to getting an answer? Why is that step we just did helpful? And the reason is because now we have an equation that only has two variables. That's much closer to we're much closer to being able to find an answer. I'm not sure what that stutter was about. That was weird. But we've got two equations here. Excuse me, we have two variables. X and y in this blue equation. Now, if we remember what we talked about on the last slide, the number of equations and the number of variables must match if we want to be able to solve it. So here we have two variables. That means we need a second equation. So what we're going to do, we're going to go back to A, B, and C, okay, and think to ourselves, how else can we combine A, B, and C so that the z's would cancel out? We know we don't want to use A and B again. We can use one of them, but we need a different pair that will cancel out Z. And I see A and C. If we combine A and C, then the Z's will cancel out. So let's copy them down here. So A is 2x minus y plus Z equals 4. And C is 4x plus y minus Z equals 14. And we see our opposite coefficients in the Z's. We're ready to cancel out. So 2x and 4x become 6x. Oh, that's interesting. The y's cancel out as well. So the y's go away and the z's go away. So we're just left with 6x equals 18. That is really good that that happened. That's not always going to happen, but if it does, we want to take advantage of that because now we have an equation, we can do this in a different color. We have an equation with only one variable. We can just solve that equation. We can divide both sides by 6 and get x equals 18. So that was nice. Excuse me, x equals 3. That was weird. X equals 3. So right away we found an answer. Or not right away, but we got to an answer eventually. So let me write that up here. So it's x equals, y equals, and z equals. We got to find all three. And x was 3, was it? Yeah, it was 3. All right. So let's scroll back down. So we have x equals 3. Now what we can do is take that x value of 3 and substitute it in. Remember, that's always sort of the second half of solving a system. It's like, okay, either we substitute or we eliminate to find one variable, and then we use that variable to plug back in and find the other variable we're looking for. It's the same thing with three variable systems. Once we find a value for a variable, in this case 3 for x, we take that 3 and plug it in, and I'm going to plug it in into this equation, the blue one, 3x plus 2y equals 15. Because since there's two variables there, if I substitute a number in for one of them, there'll only be one unknown remaining. So let's see, that becomes 3 times our x value of 3. Let me do that in green. I'm trying to color code as best I can. It's always tricky when a colorblind teacher's trying to color code. Things can get messy real quick. Anyways, it's 3 times 3 plus 2y equals 15. And then we keep on simplifying. So 3 times 3 is 9, plus 2y. Now it's time to solve, since there's only one unknown. It's just algebra 1 at this point. Take away 9 from both sides. We get 2y equals 6. Divide everything by 2. And we get y equals 3. So we found the second part of our answer. So let me scroll up. Y equals 3. Now that we have x and y, similar to what we just did with the green x equals 3, we take that and plug it into our blue equation. Now we can take x equals 3 and y equals 3 and plug that into either A, B, or C. Any of those. It doesn't matter which one we pick. I think A looks easiest to work with, so let's plug it into A. Let's do this in red. So let's see if we'll have enough space to fit it up here. So it becomes 2x, that's 2 times 3, minus y, that's minus 3, plus z, that's our one remaining unknown, equals 4. And we just solve. 2 times 3 is 6, minus 3 plus z equals 4. Then 6 minus 3 is 3 plus z equals 4. Take away 3 on both sides, and we get z equals 1. And that's our answer. Now, whenever you do one of these problems, it's always good to check yourself, because checking doesn't take that long, and it'll keep you from, or how do I want to say this? It'll help you catch small mistakes. So since we used A already, like right here, let's use one of the other ones to check. So let's use B. So let me do this in blue, I guess, doesn't matter. So we plug in, so that becomes x is just 3, plus 3 times y is 3 times 3, that's 9, minus z, that's minus 1, let's see, 3 plus 9 is 12, minus 1, and we do get 11. So we can be pretty sure that we did this correctly since we checked it and it worked. Now, if we wanted to be really sure, we could also plug them into C, but I think just plugging it into 1 is already good enough. Let's take a look at example 2. Solve the system by elimination. So it's x minus y plus z equals negative 1, x plus y plus 3z equals negative 3, and 2x minus y plus 2z equals 0. So let's put our answer line right there. X equals, y equals, z equals. And we're going to run through the same thing. And remember, the problem here, the issue, is not the math. I mean, we can add, we can subtract, we can do simple algebra. That's all easy. What makes these problems difficult for some students, for a lot of students, I should say, is we have to keep track of, it's a lot of work, we have to stay organized, and we have to sort of remember, why are we doing what we're doing? What's the decision-making process? All right, so let's label this A, B, and C, just so it's a little easier to talk about. Now remember, our first thought is, okay, we've got too many variables. We're trying to get rid of some of these variables. So which variable, x, y, or z, looks like it's the easiest to get rid of? That's the decision we have to think of. So hopefully you're thinking about that. Pause the video if you want more time to think about it. But the answer, at least from what I see, the variable that's easiest to eliminate is definitely going to be y, because We see opposite coefficients all over the place. It's all a coefficient of 1, some is positive, some is negative. So let's scroll down a little bit so we can keep ourselves organized. Now we just pick two equations, A, B, or C. We have to be careful. We have to make sure that our chosen variable y will be eliminated. It looks like A and B will do it. A and B, because that's a negative y and a positive y, just focus right there. So let's copy that down here. So A is x minus y plus z equals negative 1. And B is x plus y plus 3z equals negative 3. And now we combine for our elimination step. So x and x becomes 2x. The y's cancel out, which is good because that's what we wanted. Plus 4z equals negative 4. Again, let's keep this in mind. Let's keep this right in the front of our brain. This is better because we have one less variable. The y's are gone. We eliminated them. That's the goal here. Right. But again, if we have two unknowns remaining, an x and a z, that means we need two equations. So we have to go back to A, B, and C and look for another pair of equations we can combine where y will cancel out. Because we don't want to cancel out like another variable. We want to cancel out the same variable twice. Let's see, B and C will do it. Let's combine B and C. Let me scroll down a little bit. B is x plus y plus 3z equals negative 3. And again, we made that decision to pick B and C because we saw a positive y and a negative y. Those are opposite coefficients. They will cancel out when they are combined. C is 2x minus y plus 2z equals 0. Now we combine. X and 2x is 3x. The y's cancel out, which is what we wanted to happen. Then we get plus 5z equals negative 3 and 0. That's just negative 3. Now, at this point, this is much worse than what we had in example 1. If we think back to example 1, something really nice happened at this step because both y and z canceled out when we did our green step, our second combination step, which made things a lot easier because we just solved for x. But here, only y eliminated, or only y was canceled out, I should say, or only y was eliminated. There we go. But we can deal with this. If we look right here, we have an equation with x and z, and an equation with x and z. What we did is we sort of manipulated our three-variable system into a two-variable system. Now this is a system, the blue and the green equations, it's a system that only has two unknowns. Well, we know how to deal with this. We have to create our opposite coefficients. Again, it's all about the decision making. What do we want to cancel out next, the x or the z? We could do either one. I'm going to cancel out the x's. I think that's going to be the easiest because we've got 2x and a 3x, and we can manipulate them through multiplication to get them to get one to be a positive 6x and one to be a negative 6x. If you wanted to combine, if you wanted to eliminate the z's, then I think the smallest number, the least common multiple between 4 and 5, that would be 20. So you could multiply to get one to be a positive 20 and one a negative 20, but I think that's going to make the numbers a little bigger to deal with. So let's just try and eliminate the x's. So I'm just talked about that to show you that you have options. You have different choices that will all get you to the same correct answer, as long as you do your math correctly. All right, so let's see. We want to multiply this one by a 3 to get to a 6. And we want to multiply the green by a 2, but we need one of them to be negative. So one is positive 6x and one is negative 6x. Let's just make the 3 a negative. It doesn't matter which one. All right, so for the blue one, let's make sure we distribute carefully. So we get negative 6x minus 12z equals positive 12. I'm going to double check my signs one more time. Negative 6, negative 12, positive 12. Okay, that looks good. Now we distribute with the green, and look, I'm going to put that right under the blue just so we're ready to eliminate. Let's see, 2 times 3 is 6x plus 10z equals negative 6. I'm going to double check the signs one more time. Positive 6, positive 10, negative 6. There's nothing worse than spending 10 minutes doing one of these problems and then realizing you made a sign mistake 8 minutes ago. So I always try to be real careful with my signs. Now we see a negative 6x and a positive 6x. That's what we're looking for. We want to have opposite coefficients because now they'll cancel out. The x's are eliminated. The negative 12z and the 10z becomes negative 2z equals positive 6. And now we've got one unknown. We just divide by negative 2. And we get z equals negative 3. Z equals negative 3. We can take that, scroll on up, and z equals -3. So we found one variable. Now, you might think, oh man, we're not even like halfway there, but we're actually more than halfway there. Finding the first unknown is the hardest part. After that, hopefully things get a little bit easier because we can take that value of -3 and plug it in. But it's a matter of where do we plug it in? Because we have to choose carefully. If we choose incorrectly, we're not going to get to our correct. We're not going to get to an answer. We're not going to be able to solve the equation. For example, if I took this -3 and plugged it into a, for instance, that's not going to be helpful. Let's see what happens, because it would be x minus y plus z is -3 equals -1. This is unsolvable because there are two unknowns. So when we find our first value, our first -3, we don't want to go back to A, B, or C. We want to go back to either the blue or the green because they only had two unknowns. So I can take this -3 and plug it into any of the blue or green equations. Let's use the green one. That might be easiest. So it becomes 3x plus 5 times our value of -3. I'm trying my best to color code this. Equals -3. Let me double check that one more time. -3 is yep, that looks good. Now this is something we can solve. There's only one variable. There's only one unknown remaining. We get 3x minus 15 when we multiply equals -3. Scroll down a little bit. Add 15 to both sides. It's just a two-step equation at this point. We get 3x equals 12. Divide by 3, and we get x equals 4. A little bit more space. X equals 4. All right. Now we can take that, bring it on up to our answer line, x equals 4. And now that we have two values, now that we have a x value and a z value, now we can plug into either A, B, or C. It doesn't make a difference. I'm going to plug into A. That, again, looks simplest to me. I think that's the same one I used last time. So, in fact, I'm changing my mind. I don't want anyone to think that you can only plug it into A to find your answer. So I'm going to plug it into C, just to make things a little bit different to show you that you've got options here. If you want to plug it into A, vaya con Dios, go for it. But let's plug it into C first. So we get 2 times x, which is 2 times 4, minus y is just minus y, that's what we're looking for, plus 2z. So it's plus 2 times -3, and that's going to equal 0. Then we just run through our algebra 1. So 2 times 4 is 8, minus y minus 6 equals 0. So we get 2 minus y equals 0. I'm running out of space, so let's take away 2 on both sides and bring that up here. So that becomes -y equals -2. Then divide by -1, and we get y equals +2. Hopefully you're able to follow that work. Not my best board work ever. Right. So at this point, we're all done with that problem. But I want to check myself. I forget what color I used last time to check. I guess we used blue. I don't know, whatever. So let's see. I just used C to find my value of y. So let's use A or B to check. We use A. That looks fine. So if x is going to be 4, minus y is -2, plus z is -3. And let's see, 4 take away 2 is 2, minus 3 does give us -1. So it came out to the same thing that we were expecting. We wanted to see that -1 for equation A, and we do. So that means we can be pretty confident that we're correct. Just one more problem in this video. Just one more problem. Here's example 3. We've got x minus y plus z equals -16, and y plus 2z equals 2. And our third one is 3x plus y minus 4z equals -10. Now this one's a little bit different, but if you want to pause the video and give this one a shot on your own, by all means, go for it. But I'm going to jump right in and get right to work. What makes this one different is they all don't have 3 variables. The middle equation, which would be B, let me label them, B only has y and z. It's missing x. Now we can actually use that to our advantage here. So we've got a few options here. And remember, the most important question, the first question we have to ask ourselves is, what variable do we want to eliminate first? Because you could start with any variable. You could eliminate x, y, or z. It doesn't make a difference. But usually there's a path of least resistance, we'll say. And I'm torn here. We could either try and eliminate y or eliminate x. Now, some of you probably saw y coming because it's like, okay, yeah, we've got, they're all a 1y. We've got a couple positive, one negative. That's all good. Some of you might have been surprised when I said maybe I want to eliminate the x's because, okay, we've got an x and a 3x. We could, through multiplication, end up with opposite coefficients. But why would we want to? I mean, that sounds like more work. The advantage there is that b already is missing x. So if we can eliminate x, that can make it a little bit quicker. But I'm betting most students want to get rid of y, so that's the way I'm going to show it. That's the way I'm going to show it. Maybe if I have time, I'll do another video where I show how to do this problem by eliminating x. But anyways, let's get going. To eliminate y, let's use a and b. So x minus y plus z equals negative 16. And b is y plus 2z equals 2. Scroll down and combine. We just end up with x, the y's cancel out, plus 3z equals negative 14. And that's as far as we can go there. We've got two unknowns, which is better than 3. But if there's two unknowns, we need a second equation. So what's another pair where y will cancel out? Let's go a and c. A and c. So a little bit more space. A is x minus y plus z equals negative 16. And c is 3x plus y minus 4z equals negative 10. Scrolling down. Now we eliminate. So x and 3x becomes 4x. The y's cancel out, which is good. That's what we wanted to happen. We get a negative 3z when we combine the positive 1z and the negative 4z equals negative 26. Negative 26. Okay. Now we need to eliminate a second variable. So now we've essentially manipulated our 3-variable system into a 2-variable system. Now we only have x and z. And this actually worked out pretty nicely. My instinct was to try and match up the x's, like try and maybe multiply this one by a negative 4 to make it a negative 4x, but that kind of would have been a waste of time because if we just put the green one under the blue, I guess I'll rewrite them both. I want to try and keep my work organized. Just x plus 3z equals negative 14, and 4x minus 3z equals negative 26. We see that we're pretty much already prepared to cancel out those z's. The z's are going to go away. Oh, that was supposed to be in red. Color coding is not working out. So let's see what happens here. X and 4x become 5x. The z's cancel out. 5x equals, what is that? Negative 36, negative 40. Then we divide both sides by 5. And we get x equals negative 8. X equals negative 8. So we found our first answer. X equals negative 8. Oh, I forgot to put my answer line. X equals negative 8. And we'll put y equals and z equals while we're there. Okay. Now we've got one x value, or we got one value, it happens to be for x. Now we can plug back in to one of our 2-variable equations to get an answer for z, our second unknown. Let's use the green one just because they're already lined up. Actually, no, let's use the blue because the blue is going to be a little easier. There's a coefficient of 1, so that's just negative 8 plus 3z equals negative 14. Just plugging into the blue equation. Let's see, then we can add 8 to both sides. We get 3z equals negative 6, if I'm doing that correctly in my head. Hopefully I am. It's supposed to be 8. Divide both sides by 3, and we get z equals negative 2. Add that to our answer line, negative 2. And now that we have two values for two of our variables, we're prepared to go back to our original A, B, or C, our original 3-variable systems, and plug that in. Let's use A, I guess. Oh, actually, we could just use B, and then we would only need Z to find it. I guess it doesn't matter. I'll use A, but yeah, you can always plug into A, B, or C. I think I did this in red. I'm forgetting what colors I used last time. Not that it makes a difference. Yeah, let's plug into A. So it becomes X, which is negative 8, minus Y, which is just negative Y, plus Z, which is minus 2, equals negative 16. Let me double check that one more time. I don't want to make a mistake at the very end. Negative 8, negative Y, negative 2, negative 16. Good. Now we just solve. So we get negative 10 minus Y equals negative 16. Add 10 to both sides. We get negative Y equals negative 6. Divide by negative 1. We're running out of space. We get Y equals positive 6. Now, last thing. I mean, technically we're done. We could just leave it like that, but I want to double check ourselves to make sure we got it correct. So let's plug into, let's see, we used A, let's plug them into C. So I think I was doing this in blue. So 3 times negative 8, that's going to be negative 24, plus y is 6. Negative 4 times negative 2 is plus 8. So let's see, that's going to be 6 and 8 are 14, negative 24 plus 14 does come out to negative 10. So we're correct. All right. Hopefully that made sense. As always, if you have questions, reach out to me. Enjoy the rest of your day.